For thousands of years, humans have looked up at the night sky and asked the same question. Is there somewhere else we could go? The answer is 4.37 light-years away. This is episode 1 of the Road to Alpha Centauri. In the year 2287, a small vessel broke through the clouds of a world no human had ever touched. On board, 12 people, the children and grandchildren of the original crew. People who had been born in space, raised in space, and had never once seen Earth with their own eyes. They stepped onto the surface, they took a breath of alien air, and they sent a message home. It would take 4.37 light-years to arrive. This is the story of how humanity made that journey possible. Alpha Centauri is not one star, it is 3, a binary pair, Alpha Centauri A and Alpha Centauri B, orbit each other in a slow gravitational waltz. Both are remarkably similar to our own sun. Similar in size, similar in temperature, similar enough that seen from there, our sun would appear as nothing more than a bright star in the night sky. And orbiting the third member of this system, a small dim red dwarf called Proxima Centauri, is a world, Proxima b, a rocky planet roughly the mass of Earth, sitting inside the habitable zone, the region where liquid water could exist on its surface. Scientists discovered it in 2016. Since that moment, humanity has had a destination. But destination is an interesting word when you consider what stands between us and that world. Light travels at 300,000 kilometers every second. In 1 year, a beam of light covers approximately 9.5 trillion kilometers. Alpha Centauri sits 4.37 light-years away. That is 41 trillion kilometers. 41 trillion kilometers. These numbers are too large to feel real. So let's try something smaller. If our entire solar system, from the Sun to the edge of Neptune, were shrunk to the size of a dinner plate, Alpha Centauri would be sitting in another building roughly 3 kilometers away, the fastest spacecraft humanity has ever built. NASA's Parker Solar Probe reaches speeds of about 700,000 kilometers per hour at its closest approach to the Sun. At that speed, reaching Alpha Centauri would take approximately 6,300 years. 6,300 years. The pyramids of Giza were built 4,500 years ago. We would have needed to launch before they existed, and we still would not be there. This is not a transportation problem. This is a civilization problem. And yet, in universities, in research labs, in quiet offices around the world, people are working on exactly this. Not because it is easy, because it is the only question that matters. In 2016, physicist Stephen Hawking stood at a podium in New York City and made an announcement that sounded, to most people, like science fiction. He said they were going to send a spacecraft to Alpha Centauri within a generation. The project was called Breakthrough Starshot. The concept is almost impossibly simple in theory and almost impossibly difficult in practice. Instead of a rocket which burns fuel and fights gravity, imagine a sail no bigger than a few square meters, thinner than a human hair, made of a material that reflects light perfectly. Now imagine pointing the most powerful laser array ever constructed at that sail. For a few minutes, you fire 100 gigawatts of focused light. The sail accelerates, not slowly. In minutes, it reaches 20% the speed of light. At that speed, Alpha Centauri is 20 years away. Not 6,300 years, 20 years. The spacecraft itself would be microscopic, a chip the size of a postage stamp, carrying a camera, a transmitter, and a simple computer. When it reaches the Alpha Centauri system, it would have approximately 4 hours to photograph everything before flying past forever. No breaks, no second chance, one pass, one set of images, sent home at the speed of light over 4 years before they reach human eyes. The engineering challenges are extraordinary. The laser array alone would require the combined electrical output of a small country. The sail must survive energies that would vaporize most materials. But none of these challenges violate the laws of physics. And that, in the world of engineering, is everything. The human problem. A chip cannot colonize a planet. A chip cannot stand on alien soil and decide what humanity does next. A chip cannot look up at a sky with two suns and feel something. For humanity to truly reach Alpha Centauri, not just visit it with a machine, humans have to go, and the human body was not built for this. Beyond the protection of Earth's magnetic field, cosmic radiation penetrates every cell, high-energy particles traveling from dying stars across the galaxy, pass through metal walls, through tissue, through DNA. Long-term exposure dramatically increases cancer risk. It causes neurological damage. It may affect cognition, memory, decision-making. 6 months aboard the International Space Station is already at the edge of what scientists consider safe. A journey to Alpha Centauri. If we someday build a ship fast enough to arrive in 40 or 50 years, would require solutions we do not yet have. Scientists are pursuing several paths. Some are studying genetic modification, editing the human genome to produce proteins that repair radiation damage faster than it accumulates. Others are developing suspended animation, placing a crew in a state of minimal metabolism, reducing cell activity to nearly zero, sleeping not for hours but for years. Still others are designing closed-loop life support systems, environments that recycle every molecule of air, water, and biological waste indefinitely, with no resupply from Earth. None of these technologies exist today in the form we would need them, but none of them are impossible. The history of space exploration is the history of making the impossible merely difficult and the merely difficult routine. Even if we solve the biology, even if we build the ship, even if the engines work and the crew survives, there is one problem that no amount of technology can fully solve. Radio signals travel at the speed of light. A message sent from Alpha Centauri takes 4.37 years to reach Earth. A question sent from a ship, 4.37 years to arrive. An answer, 4.37 years to return. Nearly 9 years for a single exchange of words. A crew aboard that vessel would be completely alone. Every emergency, every decision, every discovery, handled with no support, no guidance, no voice from home. Not for days, not for months, for decades. We have never trained human beings for that depth of isolation. We have never asked a group of people to form a functioning society with its own laws, its own conflicts, its own births and deaths. In a metal cylinder, moving between stars, the engineering we can calculate, the human heart is harder to model. So why bother? Why spend the resources, the decades, the lives on a journey to a system 41 trillion kilometers away? Because the universe does not care. Whether humanity survives, asteroids don't negotiate, supervolcanoes don't ask permission. A gamma ray burst from a collapsing star could sterilize this planet with no warning and no recourse. Every version of humanity that exists, only on one world, is a single point of failure. A species with nowhere else to go. Alpha Centauri is not just a destination. It is a question we are asking ourselves. Are we the kind of species that stays or the kind that reaches? And beyond survival, beyond the cold mathematics of species preservation, there is Proxima b itself. We have never photographed it up close. We don't know if it has oceans. We don't know if it has an atmosphere thick enough to breathe. We don't know if it has something. We have never encountered a chemistry so alien that it rewrites our understanding of what life can be. The journey to Alpha Centauri will answer questions we don't even know how to ask yet. Back in 2287, 12 people stood on a world they had never seen before. They sent a message home. Simple, quiet, 4 words. We are here. It would take 4.37 years to arrive. By the time Earth received it, by the time the first human voice from another star system played through speakers on a blue planet, far away, those 12 people would be 4 years older. They would already be living the next chapter. This is episode 1 of the road to Alpha Centauri. Everything described in this video is real science, real missions, real research happening right now. In the next episode, the propulsion systems. That might actually get us there. The physics, the timelines, and the one technology. That changes everything. Subscribe. The journey is just beginning.